So I've done a few videos on small 16 by 16 matrix panels. I did a video where I put 4 of them together, and I even converted Govi's new Curtain Lights Pro to WLED and went through a lot of trouble to make it perfect. But in today's video, I'm going to take about 18 rolls of LED strips and turn them into a beautiful 50 by 50 matrix and walk you through every step. So without further ado, let's begin. Now, after a lot of back and forth, I decided to go with some 12 volt SK6812 individually addressable LEDs that have 30 LEDs per meter. And I did use the 60 LED per meter version of these in my recent Ambulet video and gaming room build that I'll leave links to in the description. But for this size panel that I'm wanting to build, 30 LEDs per meter is the sweet spot when it comes to power requirements, software limitations, and cost. So this right here is a 5 meter roll that has a total of 150 LEDs, and while I'm sure you could spend a good amount of money to make this work with solderless connections, it's going to be much easier to use my own wires, which means I need to remove the JST connector that these come with. And for this, the first thing I'll need to do is cut back the heat shrink tubing at the beginning to get to the pads on the strip. Then I'll use my solder station to heat up the joints to remove the connector. And yes, I had to then do this another 17 times. Next, I have to cut all the strips down to size, and since each 5 meter roll has 150 LEDs, I'll be able to get 3 50 LED runs out of each section. Now that we did one of the rolls, I need to do the exact same thing for the other 17. And you're going to see a recurring theme all throughout this video, and the fact that a lot of what I'm doing is by no means difficult, but when you're doing the same thing over and over again, the challenge is to be patient and take your time and not make any dumb mistakes because you're trying to rush. When we have that done, unfortunately, all the rolls also have that JST connector attached to the end as well. So once again, I'll go through and cut back the shrink tubing, pull out the solder station, and remove them just like we did for the ones connected at the beginning. So for a quick recap, I cut 18 5 meter rolls of LED strips into 3 50 LED long sections, and what you're looking at here are those 54 sections and 2700 individually adjustable LEDs. Next, I'll be taking all those strips and adding some solder to the copper pads at both the beginning and end. I'll speed through this part, but if you're wanting to learn how to solder, I made a couple how-to videos that go over the easy steps with close-up footage and detailed commentary that you can check out, and I'll leave links to those in the description. But if you're doing the math, 54 strips, each strip has 2 ends, and each end has 3 pads for a total of 324 copper pads that I applied solder to, and surprisingly, this only took about 40 minutes. Now, in order to connect all our strips together to form a matrix, I need a lot of short wires, and this probably ended up being the most time-consuming part of the entire project. I'm using some white 18-gauge silicone wires, and I'll need about 150 of these in total. And I did go back and forth on if I should use the traditional red, green, and white combo to make it easier when connecting, but I decided to only use white since I want this to all look clean and minimal when finished. From here, I have to strip back both ends of all 150 pieces, and if you don't already have a nice wire stripper like I have here, do yourself a favor and pick one up. And again, like I mentioned before, so much of this project is simple prep work that once we get done, the actual assembly part will go extremely fast. Now, tinning the wires is the part that I knew was going to take the most amount of time. This involves twisting each side, then applying solder to the exposed strands. It actually is a very easy process, but doing it 300 times took about an hour and a half total. So tinning the wire is what makes it possible for the wire to get connected to the solder on each pad of the LED strip that we did earlier on. And since the now tinned wire is longer than what's needed, I always like to trim it down to about the size of the pad for a more professional look. And we aren't going to be connecting anything quite yet, but I will be cutting these all down to the length needed. And thankfully, the step went by pretty quick and only took about 20 minutes. Moving on, and the most frustrating part of this build was figuring out how to mount a massive number of LEDs cleanly, eliminating loose wires while still creating a design that truly stands out. I first picked up some 1x2 by 6 foot long boards that I cut down to about 5.5 feet, and stacked 2 of them on top of each other, and then used my brad nailer to connect. Then I bought some 8-foot long board and batten panels that I cut down to 6 feet and connected those together on top of the wood frames that we just set up. And as you can see, I'm purposely leaving some overhang around the entire perimeter underneath the panels, which you'll see why I'm doing that later on. Next, I removed the 2 outer panels to make sure everything was lined up and even, then used the nail gun to attach the board and batten pieces to the frame underneath. Moving on, and this is probably one of the most important parts, because for a matrix panel, you want every single LED to be equally spaced from one another. What I mean by this is that the distance from here to here should be the same as the distance from here to here. So after doing the measurements, I mapped out every point along the line where I'll be sticking each LED strip so that all the spacing is correct. Once I was done with the top, I did the exact same thing on the bottom. With all my measurements done, I propped it up against the wall and used a long piece of wood and a level to make sure my coordinates were accurate and connected the dots together like I'm doing here. And having this physical line to follow is going to make my life much easier here shortly. And this step took about 45 minutes to complete, and any of you out there that are getting up in age, you already know how bad my knees were hurting when I finally stood up here. Now, pretty much all addressable LED strips will have arrows on them, and you'll need to pay close attention here. I plan on having this matrix panel start bottom left, so this first strip needs to have the arrows pointing up since the data moves away from the controller that I'll eventually be setting up. And for the next strip, the arrows will be pointing back down, and we'll repeat this up-down pattern for all 50 strips. And hopefully here you can see how spending the extra time to measure out all your lines beforehand is going to make this step much easier than doing it as you go, but at the end of the day, it still took about an hour and a half to get these stuck on. So because I used a pencil to mark all the lines, I ended up with a bunch of smudges. I bought a couple magic white erasers and went over the entire panel to get rid of anything that had smeared. Next, I used some painter's tape right above the top part of the LEDs and measured out a line that was straight across. Then I took out my 1/2-inch Forstner bit, stuck some wood underneath to help with tear out, and began the daunting task of drilling 50 holes right above the LED strips. And if anyone has any suggestions and if there's a better tool or process for this that makes clean cuts, I'm all ears. Once that was done, I took out the shop vac and cleaned up the mess. And then I peeled back the tape. And even though the Forstner bit did take a good amount of time, it got the job done and it didn't destroy the panel. And yes, you will have to do the exact same thing on the bottom. Now, depending on how picky you are, you might want to dress up the holes we just made. I found some 1/2-inch white rubber grommets that should do the trick. So this is where things really start to come together. I'll set up the soldering station and begin to connect everything up top. And because I went with all white wires and it'd be very easy to mix things up, I'm going to start by doing just one wire at a time, which will be connected to the voltage pads. This right here is the end of our first LED strip, and after I have it connected to the voltage pad, it'll get fed down the hole directly above, over, and out the opening at the beginning of strip number 2 that has the arrows pointing down, where we can connect the wire to this voltage pad. Next, I'll move the camera in closer so you can get a better idea of what I'm doing. Here I'm connecting a new wire to the end of strip number 3's voltage pad, feeding it through the hole above strip number 4, and connecting it to that voltage pad. Then it was just a matter of doing the exact same thing down the line, but again, going slow enough not to make any silly mistakes because you're trying to speed through it. Once this was done, I'm going to go back and do the same thing, but this time the middle data section is what I'll be connecting. And finally, I'll go down the top one more time doing our ground to ground. With the top part finished, I can move down to the bottom and do pretty much exactly what I just did all over again. And guys, I promise you, if you're wanting to get better at soldering, after this project, you'll for sure be a pro. Alright, so here's what I have so far, and I know for anyone that's tinkered with LEDs before, I'm sure you're easily able to follow along. But for anyone where this is all new, let's go back to my little example to explain what I just did. The bottom left is going to be our starting point. The arrows are pointing up on this first strip. At the end, this is where we connected our voltage, data, and ground wire to strip number 2, where the arrows are pointing down. At the bottom of this strip, we connected the voltage, data, and ground wire to the bottom of strip number 3, where the arrows are again pointing up. There are different ways you can set up a matrix, but this back and forth method that's called serpentine is what I normally use. From here, I'll be flipping the matrix to the backside to get at the wires so I can begin prepping everything for power and data, which I'll cover here shortly. Now, because I want to keep things as simple as possible and only deal with the wires at the bottom, I'm going to be counting 14 LED strips over from the beginning and cutting the wires in the middle. Then count 12 over, make another cut, another 12, and then a final cut. I'll flip the panel back around and pull out all the wires that I just cut, and here I'll be marking them so I know which wires connected where. I'm using black as ground, I'll use purple for data, and then I'll leave the voltage one blank. And this is where if you did use different colored wires instead of all white, you wouldn't have to do this step since everything would be color coordinated, but all white wires are definitely going to give us a much cleaner looking end result. After that, I still need to attach some wires to our very beginning LED strip at the bottom left, and I'll be marking these up as well. Next, I'll flip it back over, and for our beginning wires I just attached, I'll be stripping those back and connecting some inline WAGOs to the voltage, data, and ground lines. Then for our first cut on the right side, I'll strip back the voltage and ground wire, but I won't do anything for the data line. And on the left side, I will be stripping back all 3 of those. I'll take a 3-slot WAGO and reconnect the ground lines together, take another 3-slot WAGO and connect the voltage lines, and then a 2-slot or another inline WAGO to attach to the data line on the left side. I'll be doing the same thing for the last 2 cuts I made, and this will make a little bit more sense here shortly, but what I'm basically doing is splitting the matrix panel into 4 separate data runs, and I'm hoping to make this as easy as possible by doing only power injections at those same spots. So for controlling all the lights, I'll be using Glidopto's 4D Elite controller that comes pre-installed with WLED. This is currently their flagship model, and I've used this in a ton of my projects and I've had 0 issues. This particular model has 4 data outputs, which will be perfect for this install, and it has lots of different power options, but I'm going to try keeping this super simple and only using one single supply. The first thing I'll do is open up the voltage lever on the right side, and for anyone that hasn't used this controller yet, just a heads up, this is not open. It might feel like it's open because there's some resistance, but you have to keep pushing until it's almost upright like it is here. Next, take the included red, what looks like either a 16 or 14 gauge wire, and connect it to the voltage slot that we just opened, and then do the same for the black negative right below. They also include 2 WAGO style clips that you'll open up and connect to both the red and black wire that we just attached. From here, I'll open up all 4 data slots, then all 4 openings on both of the WAGO connectors. So to make this super easy to follow along, we'll pretend that these 4 sets of wires are the ones that'll get connected to the 4 sections that we just prepped in the previous step. And for this example, green will represent data, red will be voltage, and white will be ground. I'll take our first grouping of wires and get those connected to what will be the very beginning strip of our matrix panel like I'm doing here. And because we have all the wires marked, it should be easy to make sure they're going to the correct spot. Moving down, our next 3 wires will get connected here. The red wire will go into the last opening in our voltage WAGO, the white wire into the last opening of our ground WAGO, and our green line into the data. Then I'll be doing the exact same thing for my last 2 cut points. Now it's super easy to get everything connected to our controller because all I have to do is connect all my red voltage lines in any order to the red voltage WAGO, all my white ground wires to the ground WAGO, and then my first green data line goes into GPIO 16, the second into GPIO 12, the third into GPIO 4, and the last into GPIO 2. And I wanted to first explain it close up so you can understand how easy this actually is, because if you just saw what I'm doing here, especially if you're a beginner, you would just naturally assume it's complicated, but hopefully the way I explained it did a good job of simplifying the process. And then here's another visual of exactly what I just did. For this next part, I didn't put too much thought into it, but I wanted to build something that would hold the controller and power supply on the back so it would stay completely out of sight. Nothing fancy here, but after using a couple more pieces of wood and using some cable clips to tidy up the wires, I have something that should do the trick. Moving on to power, and I'll be using this high quality 12 volt, 12.5 amp supply that you can plug into the left side of the controller like I'm doing here. And remember, since we are using 12 volt LED strips, you do have to use a 12 volt power supply, and as always, I'll leave links to everything I'm using in the description. I'll also be using an extension cord that has a flat plug so it won't jet out and hit the back side of the panel when I plug it in. I did forget to mention I added a couple pieces of small wood on either side that'll eventually be resting on my wall, and so my wall doesn't get scratched up, I'll put some felt pads on it. Now to mount this on my wall, I'll be using the French cleat method where I'll be cutting 2 pieces of wood at a 45-degree angle. This seemed like about the easiest way to do this so that the matrix panel itself is not actually screwed into the wall and can be moved around to any other French cleat that I want to put up around my house. Here I'm attaching the first piece of wood to my wall, making sure to hit the studs. Then I'll install the second one on the back of the matrix panel. From here I'll get everything into position, plug it in, and then have my lovely wife who puts up with all my crazy project ideas help me lift it into the cleat. And just like that, we have a 50 by 50 matrix panel with 2500 individually addressable LEDs set up with no visible wires, and I can't wait to fire this up to see if it will actually work with just a single controller and single power supply. So once you download and set up WLED to your home network, go into Config, LED Preferences, and I have the brightness limiter turned on and set to 11,000 milliamps. Further down, we need to tell the program what type of strips we're using and how many LEDs are connected to each data output. Make sure to select SK6812 for the strip type. I have it set to 12 volts for the milliamp LED. Color order is GRB. The number of strips that we set up on this before making our first cut was 14, and with 50 LEDs per strip, that gives us 700 LEDs that are connected to our GPIO 16 data slot. I also changed auto calculate to dual. Our next data output is GPIO 12, and do everything the same except the LEDs connected to this one is 600. GPIO 4 is the same as above with again 600 LEDs. And then finally with GPIO 2, once again it's the same with 600 LEDs. Hit save, and then we're going to go to 2D configuration. Make sure 2D matrix is selected, the number of panels is 1, our first LED is bottom left, the strips are in a vertical orientation, serpentine is checked, which is the up-down configuration I went with, put the dimensions at 50 by 50, hit save, and we're officially ready to test this out. So when I turned it on, I was actually really surprised that everything worked first try, which means I made 0 mistakes on connecting the wires, I didn't have any bad solder joints, and there were 0 defective strips. I'll go ahead and play some of my favorite examples, but one of the reasons I wanted to do this is because WLED just released probably their biggest update ever, version 16, which is in beta. This has a bunch of new features including additional matrix functionality on top of their already impressive support. So once that release becomes official, I'll do a full review video of all the awesome things you can do with version 16 now that I have the perfect setup to test it out. Well, that about does it for this one, but I hope you enjoyed this walkthrough that should give you a better idea of exactly what it takes to bring something like this to life. Thank you all for watching, and as always, I hope you have a blessed day.
Testing. 1, 2. Check, check, check.